Okay, so let's start with, this is Unit 5. Unit 5, Notes 1. So, Unit 5. Notes 1. It might be better. And you know I love a pencil, but I'm going to do some pen because I think the colors pop out a little better for you guys to see. Okay, a system of linear equations is 2 or more lines on a graph. Okay, the solution to the system of equation, okay, the solution to the system of the equation is the point or coordinate, the point or coordinate where the two lines intersect. And intersect means cross, okay? They intersect each other, they cross each other. Point of intersection, POI, like that, is the same as the solution to a system of equation. No solution means the, how do I write this? No solution means the lines do not cross. They don't intersect, okay? And then in this case, can you think of lines that do not cross? Lines that do not cross means they are parallel. And parallel lines have same slope, same rate of change, okay? Exactly the same rate of change, the same m, same slope, the same m in your y equals mx plus b. A system of equations has infinitely many solutions when infinitely many means an unlimited number, never stops, is when they are the same. They are the same equation. Same equation or line. Okay? I'm kind of writing scribbly big, but so you can see it. All right, sounds good? Okay, so on the bottom, we have this. These are the three types of solutions. You have an intersection, parallel lines, and actually one on top of the other if this is like a double line. Same slope, same y-intercept. So different slopes, okay? This is one rate of change, this is another rate of change, right? Different slopes, then the lines intersect. They cross, they intersect, and their solution, so there is how many solutions? One solution. And in this case, this solution looks like it's over 1, up 1, 2. I'm going to say the solution is 1, 2. Where do they crisscross? Over 1, up 2, right here. Okay? Same slope, different y-intercepts. Same slope, different y-intercepts. Same slope, the lines are parallel. Parallel. There are no solutions. Okay? And these lines are equal. They're on top of each other. And there is an infinite number of solutions. If they, would sit on top of each other. All right, moving on. Second page. See, this is where you really need to print these so you have the graphs. And you need a straight edge kind of ruler thing. I have to have my tea while I do this. Okay, I'm going to graph these two lines. So, systems with no solutions. Oh, why is this has no solution here? What do I notice about their m's? Remember, y equals mx plus b. Y equals mx plus b. The m represents the slope. That's the rise over the run, remember? And the b represents the y-intercept. Okay, where it crosses the y-axis. All right, so let's give this one a shot. So if we went to graph these, I'm going to graph them just for good practice. Y equals 3x plus 2. So I'm going to start with the first one. Y equals 3x plus 2. My m here is 3. My b is positive 2. The second one, y equals 3x minus 2. So the m here also is 3, and the b is, although, a negative 2. Okay, so the first one starts at 2. 1, 2, put it up here. I start at the b. If you remember, start at the b, starts at 2, and the slope is 3 over 1. Remember, if there's no denominator, it is automatically 1. So 3 over 1. So that means rise over run. I run 1 and up 3. Put the next dot. Okay, get my handy dandy ruler. And I would graph this. I'm going to run 1, 1, 2, 3, and down 3. Notice my pattern. It will continue. All right, this is how you make that line. So that's the first one. Started at positive 2 on the y, and the slope was 3 over 1 up 3. Positive slope. Second line starts at negative 2, and I'll do this in green. Starts at negative 2, and it runs what? Same pattern, over 1 up 1, 2, 3. Over 1 up 1, 2, 3. So over 1, 2. Notice the line. It's going to be right alongside it. It's got the same slope, therefore it is parallel. Now, I'm trying to do this at a funny angle. Let's see if I can get this nice. There we go. They are parallel lines. They have the same slope. Got it? Same slope, parallel. Okay? Systems with infinitely number of many solutions. Well, what do you know about those two? They're the exact same line. So they're going to graph on top of each other. It's a no-brainer. They're going to graph an infinite number of solutions. Let's graph it. All right, are we in here? Starting at positive 3. 1, 2, 3, put a dot. Okay, what's my slope? My m here is negative 3/4. Okay? So negative 3/4 means I start here and I'm going to run, or go down 3, 1, 2, 3, and run 4. 1, 2, 3, 4. So there's the other dot. I only need 2. It's a big enough spread. And this line would do this. A negative slope going downhill, and both equations would be exactly the same. So it would be on top of each other. All right, so let's try the bottom one here. It says here to graph. Okay, so I want to do these two. So my first one here, this one, the m is 1 over 1, right? There's a 1 technically there. And the b is 2. Okay? The second equation, okay, I'm going to put this over here. The m here is 2 over 1. Now, I always put a 1 on your bottom. That's your run. And the b is a positive 1. Is that one. Okay, so let's go to the first one. Starting at 2. Up to 2. I'm going to give you a hint. This is not a bad idea to do this in 2 different colors, because you'll see the lines for sure. If you have a colored pencil, not necessary if you have regular pencil, because actually regular pencil is probably best because you can erase, because you will make mistakes. These things sometimes cause little mistakes here and there. Okay, so let's see. I started at positive 2. And I want to go 1, 1 is my slope. So over 1, up 1. Over 1, up 1. Over 1, up 1. Over 1, up 1. Now I can continue this backwards. You see the pattern, how it's going? All right. So my first line, nice and neat, beautiful. See, this works. Whoops, shouldn't have done that. All right, first line's that. My second line is this one. I'm going to start at positive 1. I'll do that one in black, I think. start at 1. It's positive 1, put a dot. And then its slope is 2 over 1. So I rise 2, but run 1. Rise 2. 1, 2, run 1. Ah, there's the intersection. Rise 2, 1, 2, run 1. Okay? I could go backwards, down 2, and go backwards 1. Now notice I'm doing the double backwards, still makes it a positive. Down 2, run 1. Still in the line. Right? These are linear. They will make a line. Ta-da! Isn't this nice? So what's my solution? Right here. My solution. Name that dot. Now you got to go back to the original grid. Over 1, 1, 2, 3. So the solution is 1, 3. The solution is 1, 3. Now, what does that mean? 1, 3, this is x. Remember, x value, this is y. So if x is 1, the y will be 3. Doesn't that make sense? If put 1 in here. 1 plus 2 makes 3. Put 1 in here. 2 times 1 is 2, plus 1 makes 3. Hello, there's your solution. Got it? That's as hard as it gets. No, it does keep. There's some equations are a little more complex. Okay, so let's keep going. Let me see. Let's try the next one. You want to try the first one, write out the M and the B first? I have to have my T. Okay, back to my red. Let's do the first one. The M over here, M on here, is negative 1/2. So that's the slope is going downhill. And the B on the first one starts at negative 1. Okay? For this equation, I'm going to do this one down here. Maybe I'll do this one in the black. The M is, what's in front of this X is really a 1. So it's 1 over 1. And the B in this equation is negative 4. Okay? So I'll make that a black line. All right? So go back to my red. Let's graph the red. So we're going to graph the red first. So I start at negative 1. So be careful here, guys, when you're reading your graph. Negative 1 is here. All right, start at negative 1. And my slope is rise over run. Remember, the rise is 1, so it's telling me to go down 1, but over 2. Down 1 over 2. So it's a downhill, down 1 over 2. Okay, so I just need so many dots to kind of line it up. Ta-da! Again, first one was a negative slope, definitely downhill. All right, down 1 over 2, so on. The second one, let's get my black pen. The B is negative 4, so I'm starting at negative 4 on the Y. Start at negative 4. And my slope is 1, 1, so it's one of those. Over 1, up 1. Over 1, up 1. There you go. Over 1, up 1. Over 1, up 1. Over 1. So bingo, we see the spot where they cross. So do you see where you had to understand Unit 4 to be able to do this? Graphing lines. Now just put two lines on one graph. So my solution here is this spot. And I got to name it, find its coordinate is 1, 2, negative 1. So it's positive 2, comma, negative 1. Will these work in this equation? This is x, this is y. If x is 2, well, a negative half of 2 is negative 1. Negative 1, wait a minute, negative half of 2. Hang on, I'm making a mistake here. If x is 2 over 1, 2, down 1. Oh, nuts, look at me. I'm reading it wrong. It's over 1, 2, down 2. Sorry, guys. Negative 2. See? Glad I was checking it. Okay, so put half, well, half of 2 is 1, but it's negative. So negative 1 and negative 1 makes negative 2. Correct. Put 2 in here. 2 minus 4. 2 minus 4 makes negative 2. Correct. So as you see how I stalled there for a second, I was like, uh-oh, I made a mistake. And the reason was I was reading the bottom line and not the axis line. That's what I was saying to you before. Be careful. These little numbers here are under the axis. Okay? All right, that's page 2. Let's see. Put that over here. Some practice ones. Okay, so let's graph these. If x is 2, and y equals negative 6, what do you think we're going to do here? Let's go, x is 2. So I find, that means if x is 2, then every value is 2 on this line. So if x is 2, it means over to 2, and it's straight up and down. When x equals 2, it's straight on the x where x is positive 2. So it's straight up and down. Okay? That's x equals 2. Y equals negative 6. Where's y negative 6? We go count down to negative 6, and we're going to cut across, straight across the bottom. In this case, it's right here, straight across the bottom. Okay, whoops. So here's my point of intersection. So the solution here is over 2 is 2 comma negative 6. Hence, there you go. Right? Let's try this one. Y equals 3. So where are the y values 3? Y values of 3 are all here, all the way across here. So y value of 3, I'm going to go straight across here. Whoops, my ruler slipped. Y is 3, and x is negative 4. X negative 4 is over here. The x values being negative 4 are everything along this line. Okay? So my solution is right in there. So my solution is negative 4, comma 3. It's the same. Like this one is 2, comma negative 6. Are we good? All right, now they throw you the curveball. These are not as easy. These we got to change to get them in y equals mx plus b form. Got to move these things around to make this work. So it kind of is that way, so you can't get crazy about it. So if I look at this, I'm going to just change it around so you can see it. Y equals 2x minus 6. Same thing. And this one, y equals, it's a negative x, so be careful. Negative x and a positive 3. Okay? So in this case, the m here is 2 over 1, and the b is negative 6. Do you get how I'm doing that, guys? I'll pause a second so you can rethink this. Do you see where the x value is negative and the 3 is positive? So your m here in this line is a negative 1 over 1. That's one of those slopes going down, over 1, down, over 1. And the b here is positive 3, but you start at positive 3. Okay? Okay, so let me go with my pen. Let's try graphing the first one a second. Okay, so the first one, I'm starting at the b, negative 6. It's negative 6, sorry guys. Negative 6. And the slope is rise over run, 2 over 1. So I'm rising 2, 1, 2, and I'm over 1. Rising 2 and over 1, rising 2 and over 1, rising 2 and over 1. I'm going to draw my line. So I got enough dots. It's like a set of stairs. Remember, linear constant rate of change. The rate of change here was increasing by 2, but it started at -6, okay? And then this one is starting at +3, so I'll do green. +3, I put a dot at 3, okay? See, starting at 3, but it is going, its rate of change is downhill, down 1 over 1. Down and over, down and over, down and over, down 1 over 1. Draw my line. So nice intersection right here. So my solution for this, name that dot, and it's on the axis. It's actually 3, 0, because 3, 0. So this is your x and this is your y. So if x is 3, if I put 3 in there, 2 times 3 is 6, minus 6 makes y is 0. Bingo. 3 minus 3 makes 0. Are you having fun? I am. Okay, crazy. All right, let's look at this one. Again, they're written backwards, but it's the same thing. So my m here is always with the x. So the m in this equation, the m, is -3 over 2. That's your slope. Your b here is +2. So I'll do that one in green and this one in red. The m here, what's my m? Is with the x. Be careful. The m is 1/2, and your b is -2. Okay? Let's start with the green. Where do you start? Where do we start with the green? I'm going to start here at the b is 2. So I'm going to go up 2, 1, 2, put a dot. And my slope is -3 over 2. So I'm going down 3, running 2. 1, 2, 3, 1, 2, put a dot. Oh, my pen is dying. Oh. Okay, hang on. What's my slope again? -3. 1, 2, 3, 1, 2. Put a dot. For some reason it does not want to do it there. Okay. And 1, 2, 3, 1, 2. Okay. Let's see. I'm going to get my line. All right. Next one. I did my green. Let's go for my red. Little Christmas colors. Start at -2. -2 is right there. Right? That's my B is -2. My slope here is positive, so it's definitely going uphill. I like when one is positive, one's negative, because that's definitely they're going to crisscross. So I'm starting at -2. My slope is, right, rise 1. Run 2, 1, 2. When you know it's the same spot. Rise 1, run 2. Rise 1, run 2. So look where they intersect. At that dot that did not want me to write on it. Okay, so my intersection, my solution here is, let's name it, at 0, we go 1, 2 over 2 down 1. It's 2, -1. Again. That's the x, that will be y. So let's look at the equation. Let's do the bottom one's easier. If x is 2, half of 2 is 1, right? Half of 2 is 1. 1 and a -2 makes y would be -1. okay? If x is 2, put a 2 in here. If you put a 2 next to 3/2, okay, the 2's would cancel out and you just get -3. A -3 plus 2, -3 plus 2 makes -1. So it works. Are we having fun? All right, so this is kind of a long lesson. All right, next page is a good practice page. It's an excellent practice page. So we're going to do the M and B's for the first. I'm going to set you up. Okay, so let's do this. M is, B is. For this one, can we see? Yep. For M is -2, put a 1 on the bottom, right? And the B is +2. And for this one, M is 3/1, and the B on this equation is +2. Ah, look at that. Where do you think they're going to cross? Isn't their y-intercepts the same? So I'm pretty sure they're crossing there. Let's graph them. Let's go back to red is +2 up 2. Starts at 2. The slope is down 2/1. Down 2/1. Down 2/1. Looks good. Oops. I don't like doing math in pen, but I'm doing pen so you can see it. So there's my red, the first line. Second line, look where it's starting. Okay, starting at 2. Whoops, my green. Starting at 2, right here, again, so we got the same intercept. Starts at 2, and the slope is 3/1. So 3, 1, 2, 3/1. All right. So 1, 2, 3. I can do it backwards as long as I keep the pattern going in the right direction. So solution is this point, and it is 0. X is 0, right? 0, but we went up 2. 0, 2. Alrighty. I'll try the next one. Okay, so this is the M here is 2/1, and the B here is +3. And do the next, this one. The M here, oh, this is interesting. The M is 1/2, right? What's with the X? And the B, there is no B, so it's 0. It starts at 0. All right, so let's go back to red. Starts at 3. So I'm going to go 1, 2, 3. There's 3. The B starts at 3. And my slope is rise over run. Rise 2/1. Now I can go down 2 and backwards 1. That's a double negative. Still keeps the slope positive. Okay? Got it? This next one. My blue, I think I did this blue, right? Okay. I'm starting at 0. So, oh, that's interesting. That's where I'm starting. What's it doing? This is a constant of proportionality one, guys. There's no other, the B goes right through 0, 0. Rise over run. Rise 1/2. Rise 1/2. Rise 1/2. Okay? Now, think about this. Okay, so this is going to crisscross something like this. Trying to get these dots right. Here, something like this. Oops. Did I do this wrong? know what it is, my red line. Notice how you could really be off by a whisker? And I was. Guys, when I drew my red line, it should have been a little bit more deliberate over this way. Yeah. Here's my solution. I didn't line up my ruler well. And the reason kind of is because I'm at an angle. I can't get over the top of it with the camera. So anyway, here's your solution. The solution point is -2, comma, -1. -2, comma, -1. Okay? And the last one we do together, and then you have homework page. All right? So my m is 2 over 1. And the b here, the b is -5. Okay? And this one, the m is -1/3, and the b is +2. Okay? Do the red first. -5, down 5. And my slope is 2 over 1. So rise 2. 1, 2 over 1. 1, 2 over 1. Rise 2 over 1. Rise 2 over 1. Rise 2 over 1. Nicely. Perfect. See if I can get this better. There we go. Okay, that's the first line. Now let's do the black one. Starts at 2, +2. So I go up to 2, starting at 2. But my slope is downhill, okay? Down 1 over 3. Down 1. 1, 2, 3. Bingo. There it is. 1, 1, 2, 3. Bingo. Okay. Got it? And your solution, the solution here is over 3, up 1. 3, comma, 1. Remember, this is the x and this is the y. Let's try it in the first equation. Y equals 2x minus 5, right? If x is 2, 3 times 2 minus 5. 3 times 2 is 6, minus 5 makes 1. Y is 1. It worked. Try it in the second equation. Y equals -1/3 x plus 2. Okay, so -1/3 times, what was x? X was 3. And go plus 2. So if you cancel here, you get -1 plus 2. And what's it make? 1. Y equals 1. Y equals 1. That's true. So this all works out. So it works it algebraically, works it graphically. That's the end of lesson 1. Okay? You have lesson 2, homework 1 is 8 problems. 4 on the first page and 4 on the second page. Okay? I would do this maybe in 2 days. Take 2 days to do this. And then we're good. I will put up the answers in a few.